Your API bill is climbing higher every single month.
Oh, yeah. It always does.
And you check the official model price card for answers.
Right.
But looking at that card is actually a trap. It is the fastest way to get tricked.
Yeah, those numbers hide the real story completely. They only show a tiny sliver of the equation.
So, welcome to our deep dive on this exact problem. Today, we are ignoring theoretical benchmarks completely.
Yeah, forget about terminal bench or SWE bench scores for a moment.
We're looking at a brutal, real-world coding showdown. It is OpenAI's GPT-5.5 against Anthropic's Claude Opus 4.7.
Right. Both models launched just a week apart in April 2026.
We are putting them through a 4-part gauntlet today. They will build a landing page and a solar system.
A space shooter and an ecosystem simulation, too.
Real seconds, real token counts, and real dollars.
This is how you actually measure an AI assistant. You test them on real daily work.
Because theoretical tests simply do not map to actual workflows. So let's start with the broader context here.
Sure.
Why are we testing these two models specifically?
Well, both companies want the exact same indie builder market. They promise agentic, long-running coding power. They desperately want your monthly API budget.
Right. And OpenAI claims GPT 5.5 does more with fewer tokens.
While Anthropic says Opus 4.7 is the king of long-running tasks.
But the official rate card creates a massive pricing illusion.
Yeah, it really does.
GPT 5.5 charges $30 per million output tokens.
And Opus 4.7 charges $25 for that million.
Input for both is $5 per million. So
Yeah.
GPT 5.5 looks much more expensive on paper.
I mean, the reality is that output costs way more, usually 5 to 6 times more, actually.
Right. Total cost is shaped by token efficiency, not just rates. The model that writes less code often wins on price.
Exactly.
I have to admit, I still wrestle with prompter myself. Tracking unpredictable AI outputs and bills is just deeply frustrating.
Oh, I totally get that. And there's a hidden tokenizer trap here, too.
Right, the tokenizer.
Yeah, a tokenizer chops text into readable data chunks. Anthropic quietly updated the tokenizer in Opus 4.7.
It produces up to 35% more tokens now.
Wow. So it slices the same words into smaller pieces?
Yes. That happens for the exact same input compared to version 4.6.
That means your bill rises even if rates stay flat.
Yeah, it is like stacking Lego blocks of data invisibly.
You really have to run your own token counts now.
You absolutely cannot just trust the marketed price. You have to measure the sheer volume of output.
So why don't models just charge a flat rate for compute time instead of tokens?
Well, a flat rate ignores the actual processing complexity. Tokens let them bill for the specific logical weight of your request.
So tokens measure the engine's actual workload, not just the clock on the wall.
Precisely.
Now we know exactly why those price tags lie. How do we actually find the objective truth here?
We force the models to build with no life jackets.
Right.
We use one-shot prompts only for this entire test. That means one single prompt and 0 follow-up questions.
0 debugging is allowed in this crucible. We are testing true first-pass quality under pressure. Yeah. It is a remarkably harsh way to test an AI. It punishes models that need back-and-forth dialogue to warm up.
But it mimics what founders actually want from AI. You want to hand off a task and get results.
Right. You do not want to hold the machine's hand.
We also need to disclose the testing harness used. GPT 5.5 ran inside the official Codex environment.
And Opus 4.7 ran inside Claude Code.
Right. Both are official coding environments from each company.
Which means we are testing the model plus its tooling. Some speed gaps may come from that harness design.
Data collection was handled very carefully for accuracy. Both environments log every single run automatically.
Right. Everything was logged neatly in JSON files.
Which is just a basic text file where each line is a data record. We pulled start and end times directly from those.
We captured exact token counts and total costs precisely. You can actually replicate this tracking on your own machine.
But wait, aren't we testing the software wrapper rather than just the raw AI brain?
Well, we are testing the tool you will actually use daily. The wrapper shapes how the model fundamentally performs for you.
Right. We are testing the car, not just the engine sitting on a desk.
Exactly. Which brings us to the actual performance.
We have built the arena. Let's see what happens when we ask them to be front-end designers.
Yeah, so test 1 was a landing page for Maya Chen. Maya runs a content studio for early-stage SaaS companies.
We gave both models the exact same detailed prompt. We asked for a calm editorial feel with minimal motion.
GPT 5.5 was incredibly fast during this first test. It took roughly 4 minutes to finish the job. It cost about $3.52.
And it returned a highly functional and clean layout. The status cards and logos were exactly as requested.
Yeah, it used a very standard Flexbox grid perfectly, but it gave off a very basic B2B vibe.
Right. It felt like a standard corporate template, not a magazine. The color palette was safe and entirely forgettable.
Now, Opus 4.7 took almost 14 minutes to finish. It cost slightly more at $4.35.
But it delivered a stunning minimalist grid.
It used high-end typography and brilliant microcopy perfectly.
Yeah.
It leveraged complex CSS grid logic for asymmetrical whitespace. It added subtle tags like Brooklyn, NY to remote.
That shows a deep understanding of professional visual identity. It understood the unwritten rules of modern studio design.
Opus wins that round easily on pure aesthetics.
Then test 2 was an interactive solar system simulation. It needed 8 planets and a dynamic speed slider.
The prompt asked for a 2D physics-based animation. We wanted it rendered smoothly in a browser window.
GPT 5.5 was slightly cheaper at nearly $3, but it looked like an ugly 2010s HTML5 Canvas tutorial.
I mean, the math for the planetary orbits was perfectly accurate.
Sure, but the sun looked totally flat and lifeless.
Yeah.
The UI elements were chunky and distinctly outdated. It just drew basic colored circles on a black background.
Right. Now, Opus 4.7 cost about $3.35. It built a truly premium orrery and almanac.
It featured this atmospheric sweeping nebula in the background. Beat. Whoa, beat it. Imagine scaling that kind of visual intuition to 1 billion daily queries.
It is wild. It achieved that by writing a custom particle effect engine in JavaScript.
The custom controls were seamlessly integrated into a frosted glass dashboard.
Opus wins again on pure visual aesthetic polish. It understands how to layer visual effects gracefully.
So why were Opus 4.7's output tokens so radically bloated compared to GPT 5.5? 58,000 versus 14,000 on that first test?
Well, it writes massive amounts of custom CSS automatically. That premium visual look requires intense stylistic code generation.
Beautiful design simply requires writing a massive amount of custom CSS.
Right, and that sheer volume drives the token count up fast.
This deep dive is brought to you by DataStack.
Yeah.
DataStack helps you monitor your API costs in real time. Keep your token spend under control easily. 2-sec silence. All right. So Opus clearly has the eye of a trained artist, but what happens when the code actually has to move?
Right, when it must react in real time under pressure.
The dynamic flips completely when complex physics are involved. Test 3 was a browser-based space shooter game.
We needed collision detection, score tracking, and game over states.
These are places where AI logic easily breaks down. Rendering frames 60 times a second requires mathematical precision.
Yeah, and GPT 5.5 built some pretty ugly geometric shapes. It literally just used neon green triangles for the player ship.
Right.
But it delivered rock-solid gameplay overall.
The ship moved smoothly across the screen. It had tight hit detection and highly responsive controls.
It managed the browser's animation frame requests perfectly. It cost $4.26.
And it took about 7 minutes to generate the core loop. Opus 4.7, on the other hand, built a gorgeous neon arcade cabinet.
It had a glowing background grid and custom typography. It even added scanline filters to look authentically retro.
Visually, it was spectacular on the screen.
But it suffered from terrible input lag. The bullets felt incredibly mushy during actual gameplay.
Why did it feel so badly on the mechanics?
Because Opus over-engineered the rendering loop drastically. It prioritized redrawing that complex neon glow over the physics frame rate.
Yeah.
It choked the browser's memory, causing the controls to lag terribly.
It cost nearly $5 and took 17 minutes. GPT 5.5 wins that round on pure functionality.
Yeah. A game must actually be playable to be useful.
So test 4 was an ecosystem simulation. This was the absolute hardest test we ran today.
It needed creatures, food, and complex evolution loops. Creatures needed to track energy, age, and vision range.
And both models completely failed this stress test.
Yeah. GPT 5.5 had weak evolution and bug spawning mechanics.
Its internal math arrays simply did not scale properly.
The trait mutation variables it wrote were too small to matter. Over time, the creatures barely changed their behavior at all.
Now, Opus 4.7 made a breathtaking vintage scientific journal interface.
It was elegantly titled Field Notes on a Closed System.
Yeah.
It used sepia tones and beautiful serif fonts for the readout.
But the internal logic broke after just 90 seconds. The entire creature population completely crashed and stagnated.
Yeah, it was a mess.
What exactly caused the simulation to die so quickly?
Context collapse inside the generated JavaScript. Opus tried to track too many overlapping CSS animations for movements.
Oh, wow.
Yeah, it caused a massive memory leak in the browser's DOM. The logic loop just gave up and froze everything.
So we call that one a tie since both broke. But is it fair to call this a tie when Opus 4.7 simulation literally died?
Yes, because GPT-5.5's evolution was too weak to function properly. Neither simulation actually achieved the prompt's main functional goal.
Got it. If the user can't actually use it, a failure is a failure.
Exactly. A broken simulation is useless, regardless of how it breaks.
Let's bring all these disparate data points together. We need to form a concrete mental model for you.
Looking at total time across tasks is wild. GPT 5.5 finished everything in 27 minutes.
Wow.
Opus 4.7 took almost 50 minutes total.
That is a massive 1.8 speed gap.
Yeah, if you run 10 complex coding tasks a day, that adds up. You save roughly 3 hours by picking GPT 5.5.
Then we have to look at total tokens used. The input was exactly the same for both models.
Right.
But Opus 4.7 burned through 3 times more output tokens.
That is 253,000 versus 82,000.
Total cost was $15.96 for GPT 5.5.
And Opus 4.7 was almost $19 for those exact same tasks.
So here's the final practical takeaway from this deep dive. GPT 5.5 is your reliable, fast-moving software engineer.
Right. It has tight interactive loops and strong foundational logic.
It understands how to build a solid back-end framework quickly.
And Opus 4.7 is your premium polished front-end designer.
It is great for slow, highly creative agent workflows.
Yeah, it understands visual hierarchy and typography on a profound level.
But does the small $3 price difference across heavy tasks even matter to a solo builder?
Well, it compounds rapidly when you run dozens of iterative tasks daily. That small gap drains your monthly runway surprisingly fast over time.
True. $3 today becomes $300 by the end of the month.
And that is exactly how founders accidentally exhaust their API budgets.
You should really run your own 30-minute test. Take one real task from your actual daily workflow.
Run it through both of these models today. Check those JSON logs to see the mathematical truth.
Make a decision based on your own actual data. Beat. I want to leave you with a final philosophical puzzle.
Oh, let's hear it.
If Opus 4.7 is the brilliant but slow designer, and GPT 5.5 is the fast, reliable software engineer,
Right.
what happens when we stop forcing them to compete?
Mm-hmm.
What if we write a script that makes them collaborate on the exact same project?
Oh, wow. Imagine combining that tight logic loop with that stunning visual polish. That is a very powerful thought to end on.
Keep questioning your tools and keep pushing boundaries.
Yeah.
Thanks for joining us.